Section 3.8 is loans and mortgages. So this is about borrowing money. At some point in your life, you're probably going to have to borrow money for a car, a house, student loans. There's lots of different ways that you can borrow money. We're mainly going to be looking at mortgages and car payments, stuff like that. So we have a new formula. This is the loans formula, but you'll notice that it's the exact same formula as we had for the annuity payouts. And that's no coincidence. So you're familiar now with this formula. But we've done a lot with finance, so let's do a little recap. So recap of which is what. Compound interest is one deposit. So you put in a chunk of money and it collects interest, and you don't put any more in. Annuity are many deposits, and they're also equal amounts for some set frequency, like every month. A payout annuity is many withdrawals, and loans are many payments. So that's kind of a way to keep track of some of the different things that we've done. So maybe this is a good thing to go on your cheat sheet. Because the hard part about these is you're going to get confused on what is what. So I'll try to point out some ways of knowing what you're dealing with. So example 1, you want to buy a new car. You can afford payments of $350 per month and can borrow the money at an interest rate of 6.9% compounded monthly for 5 years. How much can you borrow? How much interest do you pay? So this one kind of makes it clear that it's a loan formula because it's how much can you borrow. So that's how we'll pick out which ones are loans. All right, so using our formula, we know what the payments are that we can afford. So let's set this up as P sub 0 equals big parenthesis, $350 in the numerator, parenthesis 1 minus parenthesis 1 plus. The interest rate is 6.9, so I'll put 0.069 divided by K, the compounding periods, which is 12. And that's raised to the negative. How many years we have this? For 5. So 5 times 12. So that's the whole numerator. And then the bottom, you just repeat the K, R over K again. So 0.069 divided by 12. So this will go into Desmos. On another screen, I'll be putting that in. So parenthesis, and then I need the fraction button, 350, parenthesis, 1 minus, parenthesis, 1 plus 0.069 divided by 12. Close that parenthesis, and that part gets raised to the parenthesis negative 5 times 12. Close parenthesis, come out of the exponent, close the parenthesis for the 1 minus 1 plus part, and then we go down to the bottom and do 0.069 divided by 12. So according to my calculation, if I put it all in correctly, which is quite a feat, it turns out you don't really need the big outer parentheses when you put it, like I'll highlight them. These outside parentheses you don't actually need in Desmos, but it doesn't hurt to have them. Anyway, so I got $17,717.88 if we round to the nearest cent. So that means that's how much or how expensive the car can be that you can get and still be able to afford the payments. And I'm just going to check that real quick in Excel to make sure it's correct. So present value 17,717.88, 6.9%, 5 years. Yes, it comes out to be $350 for the payments. Example 2, you owe $28,000 on student loans at an interest rate of 4.9% compounded monthly. You want to pay off the loan in 7 years. What will your monthly payments be? How much interest do you pay? So you see that we can do this in Excel, but we also want to be able to do it by hand. So we're going to use the same formula, and we know this time the P sub 0 part, that's going to be the total amount of the loan, the $28,000. So that's equal to D times 1 minus, so D parenthesis 1 minus parenthesis 1 plus the interest rate, which is 0.049 divided by 12, parenthesis, and that's raised to the negative 12 times 7. So we have all of that, and then we divide that whole thing by 0.049 divided by 12. So this one is a little bit of algebra, so it's probably the hardest problem to do in this whole unit. But it's not terrible. So let's see. So I'm going to get another color out here because we're going to need some color. If I were to multiply both sides by 0.049 divided by 12, it might seem crazy, but what happens is this and this go away. And now over here I have 0.049 divided by 12 times 28,000, which we could put in the calculator, but we'd have to round, and it's not helpful to round until the end. So I'm just going to leave that. But the right side now looks more manageable. So now I can just write down the numerator part. There's no more denominator. And within that, I can take this whole inside part. I'm going to highlight it. That is just a number. So let's go into Desmos, carefully put that in, and see what that number is. And then I'm going to carry down everything else. So I got 0.2898660103. I wrote down every digit that Desmos gave me. You do not need to do that because we can round on paper, just not in the calculator. So now that that's just a number, we can divide both sides by that value. So I'm just going to put 0.029 here to round, and divide this side by that same value, 0.29, ... But in Desmos, I'm going to type 0.049 divided by 12 times 28,000. Actually, you want to start with a fraction and put in 0.049 divided by 12 and multiply that by 28,000. And then in the bottom of the fraction, use A and S so that we're not rounding this bottom number at all. So we'll just put a little note here. Do not round this value in your calculator. In Desmos, use ANS to carry it down. When you use ANS, it takes all of the digits, it doesn't round it. And finally, with that computation, I got D is $394.44. So that is the monthly payment. So maybe we put a note, this is the monthly payment on this loan. But it also asks how much interest do you pay. So for that one, we need to figure out how much we're going to pay in total. So if we're making $394.44 payments, and we do that every month, and we do that for 7 years, let me plug that into the calculator. So again, I'm going to use answer to get that 394 without rounding, multiply that by 12 and then by 7. And I came up with $33,132.55. It's okay to round there. So that's the total amount paid to the bank. And then finally, well, let's just put a note there. This is total paid to the bank. Now I can calculate how much interest that is, because the loan was only for $28,000, but we paid over $33,000. So all the remaining money is interest, and that comes out to be $5,132.55. And as you can see down in the spreadsheet, we get those same three values, but it's much easier because Excel does all that calculation for us. So it would be nice to just use Excel all the time, but it's not always an option. So it's good to know how to do it by hand. This is one that you will want to practice on your own a little bit and make sure you can do all this algebra, because I know it's a little bit crazy. Oh gosh, we have more. Example 4. Okay, so we've got 2 more examples. You have $5,000 on a credit card that charges 12% interest rate. If you want to pay the credit card off in 3 years, how much will you need to pay each month? And this is assuming that you don't make any more charges, because usually with credit cards, you keep putting more on it. So this is kind of the same thing as what we just did. So it's kind of good because we get more practice with it. $5,000 equals D parentheses, this is all in the top, 1 minus parentheses 1 plus 0.12 divided by probably 12. Yeah. Parentheses to the negative 12 times how many years? 3. Close the parenthesis. And then in the bottom, it's just repeating that R over K again. So 0.12 over 12. So if we repeat what we did last time and multiply both sides by 0.12 over 12, 0.12 over 12, then we get rid of the 0.12 over 12 in the denominator, and we get 0.12 over 12 times 5,000, and just leave it like that. Don't worry about it. Equals D parentheses 1 minus parentheses 1 plus 0.12 over 12 parenthesis to the negative 12 times 3, close parenthesis. And then we can put everything inside the parenthesis in the calculator. So put in Desmos. which I will do now. Actually, I have it in here from before, so I'm just going to edit what I have. Put 1.12 over 12 and then negative 12 times 3. There's really only 3 numbers, or no, just 2 numbers to change usually if it's monthly. So I'm going to bring out the rest of this down. 0.12 divided by 12 times 5,000 equals D, and it's about 0.3. So I'm just going to write 0.3 here, but of course, on the calculator, I'm going to keep all the digits. Then we divide by 0.3 on both sides. And okay, so I have this times, I need to do the calculations in Desmos real quick. So that's that. So I did the left side first, the 0.12 divided by 12 times 5,000, and then divided that by the 0.3, using the answer ANS. And that part, in case you're wondering, that would give you the answer anyway. So you don't need to wonder. That's the answer. $166.07 is what I got from that. And all we had to do for this one was to calculate the payments. We didn't have to calculate that other stuff, but if you wanted to check, the answers are down here at the bottom. You have your total amount paid and your interest paid down here. All right, last example. We're buying a home. So it's a mortgage problem. And the home is $147,000. You plan to pay 5% down as 5% as a down payment and take out a 30-year loan for the rest at 3.7% interest. So part A is just to figure out the loan amount. So we're paying 5% of $147,000. So that's what we did at the very beginning of the course. It's kind of like asking what is 5% of $147,000. So that's just multiplication, right? 0.05 times 147,000. And I'll do that real quick. So I got $7,350 is going to be the down payment. So I'm going to highlight that, but I'm going to say that this is the down payment. What's a down payment? It is the amount that you can put so that you don't have to get a loan on the entire mortgage, like the entire price of the house. So usually you want to aim for 20% of the home cost to put as a down payment, if possible. In this case, only 5% is going down as the down payment. So about $7,350, they're just going to pay in cash, and the rest is going to be the mortgage. So we have to calculate that 147,000 minus 7,350. So the loan amount is going to be $139,650. Okay, so loan amount, and we can put a little note here, that's the loan amount. What will the monthly payments be? Okay, so that's going to be $139,650 equals D parenthesis 1 minus 1 plus 0.037 divided by 12 raised to the negative 12 times, how many years is it? 30 years. all of that over 0.037 over 12. So now that we've seen a couple of these, we know we're going to multiply both sides by 0.037 over 12 and just leave it like that. Don't worry about what it equals. And then we're also going to take the highlighted part here, the highlighted portion, or all the stuff in parentheses, and calculate that in Desmos. So I'm just going to use an old, like our last problem, and change the interest rate, and I have to change the number of years, and that's it. So because it's usually 12, so 30, and I got 0.67. Of course, I'm rounding on paper, but not in the calculator. And then I'm going to do the same process as before. So 0.37 divided by 12 times 139,650 divided by the answer from the previous one. And I got that D is 642.79, which is the same answer. Let me highlight here. So that's going to correspond to this spreadsheet. I don't know why I have them flipped around, but it made me nervous. I was like, wait, that's not the same answer. So the payments are $642.79. How much total interest do you pay for that one? So that's C. You have to take the payments without rounding, multiply by 12, and then by 30, and you should get, I'm going to cheat a little bit, 231, and just use this spreadsheet value. But you should check and let me know if it's incorrect. D, suppose you can pay it off in 15 years instead of 30. What will your monthly payments be? So the monthly payments are going to go up because it's going to be over you have half the time to pay it in. So what you're going to do is just change the 30 to 15. So 139,650 equals D times, or D parenthesis 1 minus parenthesis 1 plus 0.037 over 12 to the negative 12 times 15. So the 15 is the only thing that changes. Close parenthesis, all of that over 0.037 over 12. And since the only thing that changed here was the 30 turned into the 15, we're going to use the same process, and I will let you know in a moment what that is. I just have to change a couple numbers on here. I think I just have to change one number, and then Desmos updates everything else. 15. All right, so let me check. Yep, that looks right. I got 1,000 just by changing that one number in Desmos. $1,012.11, which matches up with what the spreadsheet has. How much money and interest will you save if you finance for 15 years instead of 30? So the total interest that you're going to pay for the 15-year, so you end up paying $182,178, and well, let's make it $179 with the rounding for 15 years. So if we subtract the total amount that you would pay for the other one, which is, or subtract that from this number, 231,402.67 minus 182,179. That's going to come out to be, well, let me calculate that. 231,402.67 minus 182,179. That's a savings of $49,223.67. Which means if you can pay a loan off quicker than you're supposed to, you're going to save a lot of money. All right, sorry this got so long.